Hey, hi everyone. Very good evening. Hello, Govind. Good evening. Hi, Harsh. All right. So, is my voice is clear to you all? Perfect. Great. So let's get started and welcome you all to the last day of this 20 days EDL program. So today we are going to get into the last section of this 20 days. So in the last session we were looking into, let me do a quick recap and then we will get into it. So in the last session we were discussing about this particular topic, what exactly? Mm, uh, that is image detection, where exactly we are able to detect multiple images in a video and multiple images, multiple objects in an image. So that's what we have covered in the last session. So today, as per the agenda, so let me share this. Closed it. So today we are going to get into something called as text pre-processing, and then we will be winding up our today's session. All right. So almost all the topics, whatever I just mentioned in the session, we completed, we learned it. So we started from this particular part, where exactly brief history of AI, life cycle, and then Python programming part, and then we looked onto this Python data structures, and then we spent a good amount of time for pandas for our data analysis, and then we spent for data visualization, and then statistics. 2 days we spent for statistics, and then we came into this machine learning, where exactly we learned about one machine learning algorithm, that is linear regression, the assumptions, and we understood that end-to-end life cycle part. We learned it, and then we got into deep learning, different backpropagation, why we need backpropagation, how exactly different activation functions, different loss functions, different optimizers we learned, and also the next day we learned about different optimizers, loss function, and then scripting we done with respect to MNIST dataset and how to optimize our dataset. We learned it, and parameter and hyperparameter optimization, nothing but how this parameter calculation is happening by changing this weight initializer and bias initializer, how this network is going to learn it in a more efficient manner by tweaking Adam to RMS prop. That's what we learned it. And then CNN architecture, CNN theory we learned, why we need to get into CNN we learned, and then CNN for multi-class classification script also we worked on call, and then we worked on this CNN architectures like LeanNet, AlexNet, and the transfer learning concept based VG1619 we learned it, and then we got into this auto encoders part, where exactly we studied about denoising images, how to pull, how to take out the noisiness from the image. We learned it, and then detection algorithms, that is OpenCV library with respect to it, how we are taking the pre-trained XML file for object detection. That's what we learned at the last session. So today we are going to get into the last part, that is why NLP. All right. That is what today's discussion. Why NLP bag of words model. So that's what we are going to get into today's session. So let me start with this question. So why we need to learn text pre-processing is all about dealing with unstructured data. That is again a text data. So basically, what all the applications of this NLP? Let us try to understand why we have to learn this natural language processing, because we are able to see a lot of unstructured data today in the market. For example, we can say language translation. We are getting into Google when we are just giving out some things like, okay, English to French translation, or if you don't know Hindi, you can type it in English and it is going to translate you, so that you can, if you're living in city like Bangalore, if you don't know Hindi, we need only this kind of applications which can help us. So every artificial intelligence is nothing but trying to help human beings to achieve their process, or it's going to actually it is not a threat for humankind. It is going to help human beings to achieve the result in a more easy and manner, or in a more smoother manner. So that's what this particular point. And then why this is one is nothing but this language translation, and other we can say we are able to speak to Siri. Hey Siri, what is this, what is the weather outside, play me one song, play me rock song, pop song. We are able to communicate to them. And then what are the other thing we are getting into LinkedIn. So whenever we are getting a message, so automatic sentence generations, automatic word generations. Whenever we are typing a mail, automatically 2 to 3 other words that is coming in. So, and also I want to know the automatic segregation of messages in the right folders. For example, even in our emails and everything, we are having separate folders like spam folder and inbox. Even within inbox, we are having primary and also promotions, social, a lot of segregations we have. Now, whenever a message is coming into this email, automatically it is getting segregated into the right folders. Now, on what basis it is getting automatically segregated? Again, NLP plays a crucial role. So today, we are going to work on that particular task. That is how exactly automatic segregation of messages is happening with respect to spam and non-spam messages. What is that intelligence factor behind it? Because that's an AI part. Because as humans, when we are reading a message, hey, can you come to this particular place at 9 o'clock? And this is one message. The second message is congratulations, you won a lottery ticket of $500,000. So where exactly case one, the first message is it's a not spam message, it is something real. So this kind of message need to be pulled into. Whenever as humans, when we are reading it, we got to understand this is not a spam message, it's something a real message which need to provide it with some importance. So this kind of message, as humans, when we are reading it, we got an understanding this is not a spam. But the second message out, when a congratulations, you won a lottery, that's it, fine. Hey, this is spam message. So we take it under spam messages. So this kind of things now I wanted to automatically segregate it. So artificial intelligence, how we are going to give it. So that's what we are going to learn it in today's session. Able to get my point, everyone? Yes or no? Can everyone respond to me on the chat box? Govind, Jyoti. Okay, Jyoti responded. What about others? Perfect. So now, whenever we speak about this natural language processing, how exactly we are, because we are dealing with a very big text data. So there is a particular pipeline which we need to follow to overcome the means there is a pipeline like how exactly you are dealing with this. What is it? Why CNN? Because you're having an image, you're pre-processing the image with respect to CNN architectures and then giving it to the feed forward network. In a similar way, when you're having a multiple data set like a text information, all right. So now that text information need to be pre-processed so that we can have only useful information to go for a classification. Let's say we are working for a classification problem statement itself, wherein we need to make a segregation between whether it is spam or not spam. It is a classification problem statement, what we are trying to solve. Now, this problem statement, we are going to take it. Now, congratulations, you won a lottery ticket of $15,000. Please come and visit this particular place to take it. Now, within this particular entire sentence, congratulations, you won lottery. Means won lottery. That is something fine for me to make a classification between whether it is spam or not spam. All the other words I don't require. So, let's say in this way, I'm having 5,000 observations or 6,000 observations in my hand. So with respect to this data, I wanted to make classification. But means with respect, if it is one text, I don't read complete text and make classification. Only few words is going to be very sufficient for me to make a classification. So what we do is nothing but, so we take a big paragraph. Let's say if you're having a big paragraph and that paragraph, if you wanted to segment, if you want to go for classification, we take the paragraph and we go for sentence segmentation. Now see this. So from here, let me share my screen. Look onto it. So how exactly this is going to happen is nothing but this is the flow basically. You're going to take one big paragraph, all right, paragraph or any sentence. Paragraph, if it is a paragraph, we take it, we give it into text pre-processing layers. After text pre-processing, we choose text representation, or we can say we need to go for vector representation. Vector representation is nothing but taking this text information and representing the text information in numbers. Now, what is it representing text information in numbers? Let's say here we are having learners like maybe Venkatesh. Now I address Venkatesh with something like 13 or 813, roll number 813, come on here. So that's how I address with. Similar way, each and every text information can be addressed with the numbers, because machine and the backend will never understand the text information. We have to give it with the numbers. So that's why I'm just going to go with vector representation. And then vector representation, we choose a model, any classification model, and this model is going to say output, whether it is spam or not spam. This is what it is going to give it to me. 1 minute. Just give me everyone. All right, let's continue this. So now we are taking a big paragraph and then we are giving it to text pre-processing, vector representation, and then this model need to say whether it is spam or not spam. This is what this entire pre-processing. Now we are going to get into this particular pre-processing part, and we are going to understand what are all the text pre-processing layers that we need to do. So now let me erase this. Let's understand what are all the text pre-processing that we are having it here. If you look onto it, the first step is nothing but sentence segmentation. In case sentence segmentation is nothing but in case if you're having a very big paragraph. Now, firstly, you have to take the entire paragraph and convert them into sentences. Step number 2, tokenization. After breaking into individual sentences, we convert each sentences into words. So individual words, we try to do it. So, and then stemming or lemmatization is nothing but, so after once we convert individual sentences into words, we apply any one of these techniques, that is stemming or lemmatization. Any one technique we try to do. Stemming is nothing but process of reducing the infected words to their root word, we call it as stemming. Lemmatization does the same thing, but it converts the word into meaningful words that is basically understood by human beings. The point is nothing but how exactly internally this will get created. See this. Mm, now, for now, just look into the theory. You won't be able to get the complete essence out of it. But the point here, in case if you're having a very big sentence, all right. So, in few words like history, historical, historically, it will get repeated. For example, history, historically, historical. In this way, the words which is conveying the same meaning, but it will take a form of a adjective or verb, and this way it will be doing it. Now, I wanted to take this words to a root word. That root word, if I'm just reducing it to a root word, all this history, historically will be converted to a root word like history, where exactly the spelling, it won't be appropriate. So, and maybe some spellings like finally, final, finalized. So these kind of spellings, so will be, this kind of words will be reduced to one root word called as final. But if I'm doing the same process, the process of reducing the words to the root word with respect to something called as lemmatization, that last, the converted word, it will be understandable by human beings. For example, history, correct spelling, final, correct spelling. Now, why we have to do all this particular process is because, let's say you're having sentence one. This is a historic place. Okay. This is a historic place. I'm just giving a term. Sentence one. This is a great historic place. All right. Now, what do I do? This sentence is nothing but what? It is a good sentence. Let me give a label one. Now I'm just going to create like this. This is a great historic place. Now I create how many columns? Now I take, this is sentence number one. Sentence number one. Okay, this is available. This is available. Is available. Great is happened one time. What is that? Historic happened one time, and plans got happen one time. Let's take for example sentence number two. This history is a favorite subject. Is my favorite subject. Something, let me take it. Now again history. Again, I have to take something called as history again. So this historic and history is conveying the same thing. Then why do I unnecessarily need to create two columns which is conveying the same kind of information? So unless to reduce, because machine learning suffers with something called as curse of dimensionality. Curse of dimensionality is nothing but we always try to reduce the dimensions, because if it is an XY axis, if you are just giving one point, we can address this point as, okay, this is maybe 2 comma 5. If it's 3 dimension, maybe 2 comma 3 comma, maybe you have to complex 4 dimension. So when we are denoting one point in 4 dimension, the complexity is getting increased. In a similar way, machine also is facing the same kind of complexity. So we always try to make sure we are reducing the dimensions as much as we can for the purpose of learning. So for that reason, we take individual words and then we try to give it to stemming or lemmatization, so that all this kind of repeated words will get converted to its root word. The stemming conversion, it will be something meaningless, but the lemmatization conversion, it will be something meaningful. Able to get my point at least? Perfect. All right. If you're able to get it, that's perfect. Even if it is not, just be patient for a while. So we will be getting into scripting part post this. Everything you can make sense out of it. All right. Perfect. Now see this, the library to import for stemming is something called as porter stemmer. The library to import for, sorry, this is lemmatization, not stemming. 2 times I've just given it. The library to import for lemmatization is WordNet lemmatizer. Right. And then stop words removal. Stop words removal is nothing but, again, congratulations, you have won a lottery of rupees $500,000. Please come and visit. So is in these kind of words, I don't even consider for making classification between positive, whether it is spam or not spam. I don't read it. So these kind of words I again remove it. Why? Because unnecessarily again I will be creating a new features. So for that purpose, it's all comes under text pre-processing. Lowering the words. Let's say one of your word in a sentence. The same example we can pick. This is a historic place. Example 2 is history is a favorite subject. Now historic place, that H comes in lower letter, but the second sentence to H comes in upper cases. Now I'm reducing it to this lower, means I'm just making it to like stemming or limitation I'm giving it. But again, the case 2 is nothing but the sentence 2's history, the word first letter, it will be capital. Again, it will be two different sentences. Again, I'll let me create a new column. So this kind of ambiguity, I wanted to avoid it. So in text pre-processing, we always have to lower the words in order to avoid the repetition of the same words with upper and lower words. So there are a lot of other text pre-processing also you can find it here. But these are all the some steps which we are going to perform in our data. Able to get my point, everyone? Up to this? All right. Perfect. Now what we will do, so till this, let's work on one particular use case. All right. So till this text pre-processing. Hmm, let me create maybe there's our folder. So there is one data set. You can just see this later. You can practice it. So this is the script that we are going to work on. If you see the initial, the first day, I think I've shown you this particular script. So I'm just subjecting you to multiple IDs. So we worked on Jupyter Notebook. We worked on, in the last session, we worked on PyCharm. This is another ID, Spider ID. All right. So, and you can look onto the file format is nothing but .py. So I'm just going to take line by line and I'm just going to paste it in another Jupyter Notebook, and we are going to understand it. All right. So there is a data set which is in my hand. I think this is available in. One minute, everyone. See this. So this is my folder. All right. So let me open this. Right click new Python file. Let me give a name spam classification. All right. I'm just giving a new name. Spam classification here. So this is my spider ID where exactly here I'm writing my script, and here I'll be seeing my outputs and everything. So this is my data where exactly spam ham data set. I'm just double clicking on it. So if you're just double clicking on this, so all your spam messages, sorry, ham messages getting highlighted, and ham messages that let me double click on it. So free entry in a weekly competition to win FA World Cup. It's a spam message. Free message. Hey there, darling. It's been 3 weeks now, no word back. Spam message. Winner, as a valued network customers, you have been selected to receive $900 euros spam message. So you're having a lot of spam messages here. All right. So see this, how many spam messages we have. We do have a lot of spam messages in our hand. All right. A lot of spam messages is available. So total number of observation sizes, 5,574 observations we are able to see in this particular data. Now we have what are all the spam messages and what kind of non-spam messages. Non-spam, I call it as ham message. So spam versus ham message. That's how I'm just giving a label. So now first this data set need to be imported. So what need to be done? Import pandas as PD. All right. Now I'm just clicking on F9. So that is a shortcut key to do that, F9. So now it is done. Then PD dot, I wanted to read this particular data set. So read underscore so CSV. So because, and the file name is, what is that? SMS spam collection. So let me copy, right click, copy. Let me give it here. So call complete path I don't want. So anyway, I'm in the current directory. And it is a tab separated file because it's not a comma separated one. So SAP is equal to, let me give it, it is a /t. Now this data, if I'm right clicking, if I'm just clicking on F9, it will be displayed here, how exactly the data is. But I wanted to store it into a variable and I have to take it. So let me just store it into something like spam data. All right. Let me click on F9. So this information got stored into spam data. Now here I'm having something called as variable explorer. Let me double click on it. This will get open. But if you see this, I'm just expanding this. If you see this column name takes ham, and the first observation get into column name. The first observation get into the column name here because this data set is not having any column name. In case we have already looked onto the Panda session, we had order ID, item name, item choice description, all the column names we have. The zeroth row will be treated as a column name. Here we are not having any column name. So the zeroth observation got into the column names. Now we have to change this. We can just give a label to this. So this will be taken as one of the observations. Able to get my point, what I'm saying? All right. Jagdish, Jyoti, somewhat, Harsh. Yes, sir. Perfect. See this, just observe this if you're not getting it. Zeroth observation is go until direct point, right? So let me close this. What is your zeroth observation? Zeroth observation is zeroth, go until direct point. So zeroth observation has been treated as a column names. Now I wanted to change this particular column. So let me click on it. So here, if you just give a comma, there is something called as names here, which is set to none. So let me tweak this names is equal to, since it is two columns, I have to give it. So in a list, the first first column name, I would like to give it like something like maybe labels, or we can say label. And the second comma, the second thing I would like to give a name like something like messages. All right, message. Now let me click on F9. Now if you see this, still it is not getting reflected. Oops, 1 minute. F9. Okay, now it is done. Let me double click on it. Now if you see this label and messages column names, we created it. Right, Srinivas, correct. Spam ham data. All right, fine. Let me give spam ham data. But in case if you're doing it again, one more data set will get created with the same name. All right, maybe we can right click on it. Maybe you can remove it. Why to have names remove? Okay, spam ham data. Now data set has been imported. Now what are all the steps to be done? As nothing but I need to go for text pre-processing. So to deal with this text pre-processing, there are some packages which we have to deal. Some packages names are NLTK, Natural Language Toolkit. Some packages names are Genism, and we are having Spacey. Lot of packages we are having in our hand. Let me try to use one packages with respect to it. We call it as NLTK. So NLTK is nothing but Natural Language Toolkit. So two files separated or one file only? One file only, Srinivas. Within one file, within the say one variable name, spam ham data, I'm having this entire information. Yeah, all right. Oops, cancel. Now I imported my particular data set. Now slowly, one by one, I have to perform this data cleaning. So what I'll do is nothing but, so what I want to do, that is, first step is nothing but stemming. So sorry, splitting words into individual words. So to deal with this kind of text pre-processing, one of the very important package that we have to have is nothing but our regular expressions. All right. To deal with text pre-processing, we need this regular expression. So what I'm doing, I'm going to import RE, regular expression. Let me click on F9 to execute that set. Or else you can come back here, I can explore this ID, you would be able to do. So now what I'm going to do, I'm just going to create an empty, something like empty list. All right, corpus is nothing but, here I'm having one empty list here. You can think of an empty list, or you can say it is a cleaned data. All right, cleaned data, you can take it into like this. For now, clean data is empty. Now, what is my idea? I'll get into this particular data. I'll take only this messages, every observation at once. I'm going to tokenize it, apply lemmatization or stemming, and lower the sentence. And then I'll just put it back. And that clean data, I'm just going to store into this particular process one by one. So this need to get processed one by one. So because one by one, I need to take it for I in range of, let's say the 0th observation till length of, maybe length, or you can just note down this number. You can just try to give maybe, okay, 5572, right? You can directly give, what should be the ending number? 5573. All right, you can 5573, so that 0th number, first number, second number, everything it will be taken. So colon. Now what I want to do with respect to it, first I have to split my sentences. So what I'll do is nothing but, let me take this spam ham data. And before even splitting it, so if you see here, with respect to the data, we are having this number spam, let's say numbers 0733. Do you think this numbers and everything, is it going to um, contribute for whether it is a spam or ham? Numbers is it going to contribute? Not really. Congratulations, you won lottery, right? So this kind of information, is more than sufficient for me to make a classification. So what do I do? Except English words, that is, we can say except English alphabets, I'm going to remove all the other terms out. So what, even the spaces, is everything I'm going to remove it off. So for that, what I'm trying to do with respect to this regular expression, so let me remove that off. So you can do regular expression dot. There is something called as a replace. I've imported F9 import dot re replace, right? Okay, substitute. Sorry, there's something called a substitute dot substitute. All that we click on it. First one is nothing but pattern. Pattern is nothing but, I'm just taking, hey, except this A2 small z and capital A2 capital Z. All right, and I'm just enclosing this within a list, and I'm saying an apostrophe, there's upper cap, that is except A to Z A to Z, let it be smaller uppercases. If you accept this, replace everything with one empty space. And string is nothing but which is my data. My data set is available in spam ham data set. Spam ham data. I need to locate which column. For data location, we know we have to use the single quotes. And which observation, square bracket, this ith observation. Ith observation. So I do this and let me store it into this, maybe something like a review, or let me take it in review. All right. Now let me say this review dot, so not review dot. Let me say, let me, for each and every observation, I'll do this and I'll append it to this particular empty list, clean data. So for now, let me click on this F9. So for now it is empty list, nothing is available. Now what I'm doing, so here clean data as a list. I think you already worked on one function called as append function. Append function. I wanted to append this review. All right. Now what will happen is nothing but 0 will get stored into I. It is going to pick up the 0th observation. That is 0th observation, go until direct point, and except if it is finding this comma, it will give a space. Crazy, it will give a space, and any other 3 dots, it is going to give a space. And after giving a space, I'm going to append it to this 0th and first observation, second observation. In this way, one by one, it will try to happen. Let me copy this. Let me click on F9. Invalid syntax. That's what it is giving. Maybe we try to remove this off. Again, I think one more bracket. F9. Again, invalid syntax. 1 minute. Let me try to take it. Okay. Within single quotes, we have to give it. All right. So within single quotes, again within single quotes, let me take it within list. All right. Let me take it within list. Let me run it. Okay. 5572 is an error. Yes, Jyoti, it can be removed. So let me give 0th observation to 5572. Let me execute it. F9. Okay. Now it is done. Now if you look onto this particular part, all right. See this is it's not and dot dot everything is removed. Let me double click on this. All this dot 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 has been replaced by empty. What is it? Empty spaces. All right, and all this thing has been replaced by empty spaces. And you can think take of this example. All right, you're watching here. Maybe if you scroll down, all these numbers. See this here, I got number earlier, that numbers got removed. So it's just within a fraction of second, everything got removed. All your text information, numbers, punctuation. This 3 dots are nothing but there are still some information I'm having it at the time. It's not a punctuation mark. All your punctuation marks, special characters, everything has been removed. Now, after removing it, I wanted to go for split ups. So I have to perform tokenization. Individual words, I will be taking it up. So re dot, I'll be using the split function. Again, pattern. Maybe if it is finding a space, okay, from which string, just if it is finding a space, split it from which string, review, because it is going to pick up the first observation based on spaces. It is going to take the review and again store it back to the review itself. Okay, what it is 0th observation, getting into this I, 0th observation. For the 0th observation, except English alphabets, place everything with space and store it into something called as review. Again, RE dot split with the clean information. If you find the space, go for tokenization. This part is tokenization. And after performing tokenization, store it into this particular list. Let me copy. As of now, it is empty list. So let me copy along with this F9. Now this is done. Let me double click on it. Now if you see, all this empty spaces, everything is going to get constructed as a list itself. Sorry, individual tokens. You can double click anywhere. Now we got individual tokens. Now the point is nothing but we will be applying stemming or lemmatization. We can just try to do. All right. So maybe before that you can just lower all the words. That's also can be done. So what I'll do is nothing but again this review dot re dot lower. Lower, is it not available? Lower, how I done it? Okay. Review dot lower, it's available, right? this review dot lower. I'll do this and I'll just store it into my review again, so that it's also on perform data cleaning F9. Okay, list has no attribute called lower. So now it becomes list, right? Individual list of individual tokens. That's what I got it. So before converting into list, I need to take this step before. Again, rectifying from the mistake itself. Now individual informations got converted into, again, it is a string basically. If it is a string, I can just convert it because that's what we learned it in our Python programming session. So now it is a string, only it is taking numbers, taking out numbers, punctuations, and everything. It is still a string. Now I'm lowering all the strings. Now I'm just taking into tokens. Let me again execute it. Till now, I'm just having this capital G, capital A and everything. Now let me just execute it, F9. It is done. Now let me see. All words got lowered, lowering all the words. Again, one of the text pre-processing. So after this very important step, we call it, now I will be applying stemming or lemmatization. All right. So to go with stemming or lemmatization, I need one library called as NLTK. So with respect to NLTK, I'm having that support. So import NLTK library, sorry, NLTK, natural language toolkit. Let me click on F9. So it got done. So now what I'll do, so NLTK, and also we have to download this stop words from the internet. We need to do this NLTK dot download. Maybe I'll take all these particular packages at the first line. You will understand now. NLTK dot download. I want download stop words. All right, let me click on F9. Okay, downloading packages stop words, because stop words removal also need to happen, right? So downloading package is got stored into C users, X1 Yoga app data roaming. So that's where it got stored. So let me just get into this particular part. So now what I wanted is something. Let me get into C users X1 Yoga. I wanted to get into this app data somewhere it's hidden. App data. Okay, here it is, app data and roaming. This is the path it showed me. And here NLTK data. All right. And here I'm having corpora, stop words. And see this, these are all the list of stop words which got downloaded right at this particular place. I've downloaded it already. So it is saying requirement already satisfied. So Arabic and let's say English stop words. Let me double click on it. I would like to see it in Notepad. So these are all the stop words. I, me, myself. So if I'm scrolling down, so these are all the stop words. In case if I'm finding any stop words like this in my data, it will be taken out. And if you wanted to add some other list of words, you can also add it in this particular list. So this one, it's not with respect to only one language. We have multiple languages. Now we imported this down. We downloaded all the stop words, but specifically we need only this English. So we will also call this particular English in a while. All right. Now we downloaded this particular software, sorry, stop words. Now we have to import this in order to go with a stemming or a lemmatization. I need some packages. So that package is available inside from NLTK dot stem. All right, dot stem dot porter dot port. This is a package again. Import. Let me give a tab button. I'm having porter stemmer for stemming purpose. Yeah, stemming purpose. Let me click on F9 to execute it. Now, once it is done, let me this import. After importing, we have to call this particular class. So porter stemmer. Let me call this and let me give it to something called as PS, porter stemmer. All right, porter stemmer. Let me click on F9 now. Now it is done. So now what I wanted is nothing but two steps I'm going to do at once. What I will do now, individual tokens, right? So we just splitted it. Now it is in individual tokens. I'm going to check with respect to this. Is this individual tokens, is it a stop word or not? If it is a stop word, I'm going to remove that off. If that is not a stop word, I'm going to perform stemming. Able to get my point what I'm saying? Just observe this carefully. In one step, I'm going to perform two tasks. That is, now it is individual lists, individual words. So that word, is it a stop word or not? I'm going to check it. If that word, if it is not a stop word, I stem it and again store it into review. If that word, if it is a stop word, I'm going to take that off. Or I'm not going to stem it. I'm going to anyway remove that off. That's it. Able to get my point? Jyoti, yes. Jagdish, Dr. Leela, Harsh. Perfect. Awesome. Wonderful. Now see this. So I'm going to do with respect to something called as list comprehension, which we've already learned. So list comprehension, I'm going to use square bracket. So what I'll do for word in, I think we already learned this for loop. So this is a review. Every individual words I'm going to take it, copy. Every individual words I'm going to take it. So for word in review, if that particular word not in, all right, not in, we imported already stop words. Stop words dot, I think stop words of English. All right, because stop words we know it. If that word, if it is not in stop words of English, I just do ps dot, where exactly we have stored it here. PS dot, we apply 1 minute. Let me just give it space. We take that particular word dot, we apply stemming. We just stemming. Let me double click on it. So which word I have to do it? So word, the words which is not available here, I just stem it. That word I stem it. In case if this part is not understandable, you should have learned this list comprehension already. I think I've already asked you to learn about this. How in one line I'm writing it up. The point is list comprehension. If you're not aware of this, try at least going through this once. Now what I'm doing, I'm just for see this for word in review. Review is having individual words. If you look onto it, first zeroth observation, go. All right. So this word go will get into this word. All right, individual words. First observation. Anyway, zeroth observation is getting into I. And the zeroth observation, I'm just going to remove all these characters and lower it, split it. Now the zero sentence having go until direct point and everything. So now again here I need to go through all the words. So I'm writing a for loop for review in words. So now I just pick one, go and store it into word. If that go, if it is not in stop words, I'm going to stem it and I'm going to store it into review. Let's take, for example, the word is E or N. Let's say N. So now word is N. If N not in the stop words, only then I'm going to do it. The word, if it is in stop words, that word is going to be removed off. Able to get my point now, what I'm saying? Jyoti, got it? Jagdish, yes. Anyway, so now, perfect, everyone. All right, Jagdish, Harsh, wonderful. Now again, after storing this, again, let me take this and append it. All right, so again, let me execute this. F9, there is a mistake. Stop words is not defined. English, okay. Download stop words, but where we have imported, yes, importing is done. Import stop words. Import stop words. So this is one, and also English. Now let me execute. Stop words is not again defined. Why is it again? Okay, stop words dot words. That's how we have to call it out. So let me say stop words dot, because we are having different languages. So stop words dot words. Let me again execute it. F9. What is it? Where we are using stop words? In line number. Import stop words dot words. But English, that's the same thing which I'm trying to do. A bird, not in 1 minute. Is there any mistake that we're stemming a particular word and I'll try to take it? I'm not finding any mistake. Okay, no module called stopwords. Fine. Let me copy this maybe. We are performing it right. Just trying to write it again so that you will understand the flow. PS dot stem that particular word. That's what I want to do. Word. Let me. What's the mistake that we are doing here? Okay, we have to import this. See this step we missed it. From nltk.corpus, this step we should have done it. Yeah, stopwords not defined. So from nltk.corpus, we are having this particular import stopwords is not working. So from nltk, you have to take the stopwords here. So that's the point it is throwing us an error. So let me execute F9 and then let me execute this particular the same thing. Right now it is taking some time. All right, because since we are using this respect to NLTK library, so we need to take stop words from that NLTK library, not the package which is already available outside. So from nltk.corpus, I want to import the stop words. So from that stop words, I'm just English downloading all more specifically that English stop words. Now 5,500 observations, I'm able to see it here. So for that reason, this is taking some time. Let's wait for a while and see how exactly this is working. This will take some time basically. Okay, now it is done. Now if you look onto it, so most of the see the stemming. So we have applied stemming, right? Some see this earlier it showed like crazy or craziness and available we had. So if I'm applying stemming, the words will get converted to its root word, and I said it won't be something meaningful. That's the term which I mentioned earlier. If you see this fifth word is nothing but where is that? This one, spam data. Spelling is what? This is my original data. Crazy available. So this is the original word. So we applied stemming. Because of that, it got reduced to some root word, but that is not something meaningful. Got my point, everyone? Stemming, crazy available. Jyoti. Yes. But in the same place, if I'm applying stemming, all right. But for stemming, you have to import some other package, one more package that is from NLTK dot porter, I think so. Dot stem. Import maybe directly, I think directly from here. Import WordNet lematizer. All right, that's what the package name, WordNet lematizer. Let me click on F9. And the way how you initialize this particular class, WordNet lematizer. Let me give it to something like WD lematizer. F9. Let me give it. Now instead of this particular part, what you can do, WDL dot. We have lematize. Oops, we have dot lematize. So lematize which particular word? That individual words. All right. Now let me execute it again. Okay, in variable explorer. So again, this will take some time. So since it need to process for all your 5,500 words, this will be taking some time here. All right, now it is done. Let me check it now. This is my clean data. Now see this. The words which got converted, crazy, available, it is meaningful words. Now you got the difference between stemming and lemmatization. Only Jyoti is responding. Hush. All right, I understood this. Perfect. So now lemmatization, but still the words are something like individual tokens. Now I have to this whether the sentence is it a ham or spam. That's what I want to do. So basically, now again I have to based on the spaces because now it is a list, right? So based on each and every sentence, it's a list. Now based on this particular spaces, again I have to combine back to form an original or a complete sentence. So what do I do? Not to combine it again with some spaces dot join we have. This again a string function. Join what? This review. Copy, paste it, join that review, and again store it back to the same review. All right. And then after storing it back, append it to this clean data. F9. Okay, indentation error. All right. So in this way, whenever you're seeing any kind of scripts, try to take it line by line and understand what exactly the reason is, because we are all in the learning phase. So if you're just directly looking into the script, it might seem difficult to understand what we are doing, why he's just like this, why they have done it. So in this way, you will get a lot of confusions, but just try to go step by step, decode it. In this way, you can just learn it better. Okay, yes, you will be facing some errors, but this kind of learning, if you're taking step by step part when you're performing your self-learning process, it will be more helpful. Fine. So let's, I want this clean data to be perfect, cleaned data. So this is what I meant by text pre-processing. Now it is done. Now it need to be a proper English sentence. All right, now I got it. Go direct point crazy, available things out. Everything is lowered and there is no, now my data is completely clean. You can just look into any data set, it is completely clean here. All right, in case if you want to perform any other text pre-processing also that you can do, but here that's not my code. So what we have done, we taken the entity data set, we given it to this text pre-processing layer. Now we got this cleaned data set. All right, now after this part, the next step is what? What is the next step I mentioned? What is the next step I mentioned? Nobody noted. After text pre-processing, what is the next step? All right, nobody noted, I think so. It is nothing but vector representation. I'll try to take some notes whenever the chart is everything is given to you. All right, so it's called as vector representation. Vector representation is nothing but here I'm having individual words. Now machine will never understand individual words. I have to take these individual words and represent in numbers. So for number representation, we are getting into right, Deepan. So for taking this English sentences and representing into numbers, I'm getting into vector representation. So for that, we are having a lot of models here, but I'm just going to touch the very basic model so that this is a starting point here. Now, the very base model is nothing but we call this bag of words model. See this? How exactly this bag of words model in the sense it's not a classification model, it's just a vectorization model. So bag of words in short, we call it as BOW, or a bag of words. So in order to implement bag of words, I need something called as count vectorizer. So now see this, let's take, for example, we are having three sentences like this. That is, sentence one, she is a good boy. Sentence two, she is a good girl. Sentence three, boy and girl are good. Now I want to say whether this sentence is it a positive sentence or a negative sentence. I want to make a classification. So from the sentence one, you're taking after, if I'm giving this entire thing to the text to pre-processing, the output of this is nothing but I will be getting he, she, he is, it's going to be a, because let's take, for example, human beings. He is a good boy. Now, as human beings, I'm good is more than fine for me to say this is a positive sentence. She is a good girl. Again, good is sufficient for me to say this is a positive sentence. Boy and girl are good. Again, this is a positive sentence. He is a, I don't want it. So what I'm doing, if I'm giving these three sentences to the text pre-processing layer, the output of that, it is nothing but what? Good boy from sentence one. That's what it is I've written. Sentence two, good girl. Sentence three, boy, girl, good. The rest things are going to be removed off because those are all the stop words. Let's take it in that way. Now what we need to do, we have to represent this in numbers. So how I'm trying to do, so I'm just trying to represent this particular data in this format. That is, every row takes sentences. Sentence one, sentence two, sentence three. Now sentence one, what are all the unique words I got? Good and boy. So first word good I created as a one column, boy I created as one column. Okay, second word good girl. I already created one column called as good, so I'm not creating a new column. But girl, I did not create it as I'm creating a new column called as girl. In sentence three, boy, girl, good. So I got boy already, girl already, good already. In case if you have not lowered it, the first letter is B. After text pre-processing, the first letter will be capital B here. I should have created one more new column. So to avoid all that part, we are including lowering all the sentences, lowering all the words into in our text pre-processing itself. Now we got the sentence rows and columns. We got it. Now what we want to do, sentence one. Sentence one, is it having the word good? How many times it is having the word good? Sentence one. So I represent one. Sentence one, how many times it is having the word boy? One. Sentence one, how many times it is having the word girl? Zero. So zero. Sentence two, how many times good is happening? One. How many times girl is happening? One. How many times boy is happening? Zero. Sentence three, how many times good is happening? One. How many times boy is happening? One. How many times girl is happening? One. So now I got it. So now, if you call, this is nothing but this kind of representation or the matrix, we call it as document matrix or vector representation. Now everything is in numbers. That is, if I wanted to say, or if you wanted to address the number good, all right. So how can I address 111? This represents good. How can I address the word boy? 101. 101, that is nothing but boy. 011 is nothing but it is girl. So now I got for one word the vector representation I got. Able to get my point, everyone? This Jyoti, that's a biggest problem here. That's a major drawback. We'll talk about it anyway. So now this is nothing but what the number representation. We just got this particular number representation. But how exactly the pattern will get trained is nothing but how exactly pattern will get trained. If 1110, this is a positive sentence. If 101, this is a positive sentence. If 111, it is a positive sentence. So in this way, I will be getting this kind of information from this particular data. All right. So now the number representation I got. In case if you're having some sentences like this, he is a good boy and a good cricketer. Again, sentence one is having how many times the word good. After pre-processing, I will be getting good, boy, cricketer. Those are the things I'll be getting it. So good will be created in one column, boy will be created in one column, cricketer. Sentence one is having two times. The word has happened two times. So I'll be taking two. So your bag of word is nothing, but it is just going to take each sentences in observations and unique words in columns. So that's how it is trying to work. Now, but there are certain ways how you can just pick up your columns. That is, we go with unigram. Unigram is nothing but, hey, I wanted to pick up only one word at once. If you go with bigram, bigram is nothing but I want to pick up two words at once. That is, in sentence one, how many times the word hi and hello is happening together. Welcome back is happening together. Finding out is happening together. It will take one word and also two words. That's what bigram as one columns. Trigram is nothing but it may take, okay, it may pick up a one word at a time or two words and three words at a time. It will go up to three words. So that's what this particular trigram. So to create one column, I can go with only one word at once or two word at once or three word at once. So these are all the options which I'm having in this particular bag of words technique. That is unigram, it takes only one word and find out the total frequencies. Bigram, it takes two words, one and two words we can say. Trigram, it takes one comma two comma three words. It's having an option to pick up the number of words to be as a column. So that's what the point we are having it as an option. And the next point to be noted is nothing but there are similar terms in NLP. That is sentence. I call it, say I'm having these many sentences here. The sentence, I also address it as a document. I'm having a very big document in my hand. Or we also address it as corpus. Hey, this is a very big corpus. So these are all some technical terms what we call for a bigger data set if you're playing with text data. All right, a lot of new things here we're learning it. Just note it down when you're coming back, you can refer it later. But the major drawback of this particular bag of words model is nothing but it is giving equal importance to all the words. That is, see this. How this pattern will get trained, or we can say this, let's take this example, 2101, that is, here it is going to pick up the total number of occurrences. Here, if you look onto it, again occurrences. Now again, 110, which is nothing but sentence one, is it having the word good? Sentence one, is it having the word boy? Sentence one, is it having the word girl? So it is going to give equal importance to all the words. But is our human brain working the same way? Do we look into good and boy to say whether it is a positive or negative statement? What do you say? Or only good word is fine for us? What do you say, everyone? Only good is fine, or do we need boy to make a classification between whether it is positive or negative? Good is fine. All right, which means that only good is important for classifying, right? But if you look onto this particular bag of it is giving equal importance to all the words present in my data. So that is a problem. So to give importances to some unique words, or say some importance, to give more importance to the correct word, I'm going to the next technique we call it as TF-IDF technique. We call it as term frequency, inverse document frequency. So if you look onto this particular process, term frequency, because with respect to bag of words model, it is converting words to individual words. But the point over there is nothing but it is not performing a very good job because it is giving equal importance to all the words. To avoid that particular part, I'm just getting into the next vector transformation technique. I call it as term frequency and inverse document frequency model. So it is having a mathematical equation where exactly term frequency is nothing but number of repeated words in a sentence divided by number of words in a sentence. Inverse document frequency is having a mathematical equation log of number of sentences divided by number of sentences containing the words. So we will multiply term frequency with inverse document frequency and we represent our data. Now see this, sentence one, sentence two, sentence three. Here I'm having three words, the same example I've taken, and my task is to make a classification between whether it is a positive sentiment or a negative sentiment. After pre-processing, what are the unique words you will get? Good boy. Sentence two, you will get good girl. Sentence three, boy, girl, or good. Now the same thing, take all your sentences in rows and unique words in columns. Now, but here, earlier we have seen sentence one, how many times it has happened? Good, that's what we have written. Now it is not like that. Now it is TF multiplied by IDF. Now what is this TF? Number of repeated words in a sentence. In sentence one, how many times good has been repeated? Only one time. So the numerator is 1 divided by number of words in a sentence. So in sentence one, how many words I have? 1, 2. So I go with 1 by 2 multiplied by inverse document frequency is log of number of sentences. So in this example, how many sentences I have? 3. So number of sentences is 3 divided by number of sentences containing that particular word. So how many sentences is having this particular word good? 1, 2, 3. So I go with 3 by 3. Let us go with this one. So sentence one, how many times is this TF? TF is nothing but number of repeated words in a sentence. Sentence one, how many times is the word boy has been repeated? Sorry, in sentence one. Sorry, in sentence, sentence one, how many times the word boy has been repeated? Only one time. 1 divided by number of words in a sentence. In sentence one, how many words I have? 2. So 1 by 2 multiplied by log of how many words, number of sentences? 1, 2, 3. 3 sentences I have. So 3 divided by number of sentences containing that words is nothing but how many sentences containing the word boy? 1 and 2. So the denominator is 2. Sentence 1, TF, number of repeated words in a sentence. Sentence 1 is not at all having the word girl, so 0. So in this way, I try to represent all this kind of information. Sentence 3, if you take, again TF-IDF, we can calculate it. Now if you're doing it, log 3 by 3 is nothing but 0. Okay, so this value will be 0. Here I'll be having some value, 0. And again, log 3 by 3 multiplied with anything 0, 0. Here I'll be having some value, 0, some value, some value. That value is nothing but you'll be getting like this, 0.088 and everything. But again, the problem here is nothing but sentence when it is giving weightage, right? It is giving weightage to some words, but more weightage is going to the word boy. That is 8% weightage. But to the word good, 0% weightage. So it is giving weightage to some words, but that words are something not related to our task, or humans are not going to give some more weightage to that words. I'm expecting more weightage to be given to the word good, not to that word boy. So again, it is going to be a problem, TF-IDF. So by that is overcoming the limitation of this bag of words model, where exactly we wanted to give weightage to some words which are very common, but here it is a problem. So to overcome this particular part, and also here we are not understanding the similarities or similarity between the words, nothing we are getting it. So the word embeddings for good, each and every word embedding for one word good, 0, 0, 0, 0 0.080, 0 0.088, it's very, very poor. So we are not using this kind of techniques mostly in the real time, if it is a very for language translation, everything. But this part is sufficient for us to go for a classification between whether it is a spam or not. So we will use this particular technique now in our program to make a classification. So to overcome, to understand the similarity and ever see this, here I just given some drawbacks. So there are high chances with respect to TF-IDF, there are high chances that it might give importance to uncommon words. It is just breaking the sentences into words, but it is not understanding the similarity between the words or the context. So to understand the similarity between the words, I'm going to get into the next model called as word to vec, and also the context, we are going to get into some advanced model called as BERT. But we are not going to get into that. We are just going to understand how exactly bag of words model will work and TF will work with respect to scripting now. Able to get my point, everyone? Is this math clear? Jyoti, Jagdish, Harsh, Srisha. Perfect. All right. Now let's take a quick 3 minutes break. So now we are going to use this text pre-processing is done. Now vectorization we are going to do with respect to scripting part. And after vectorization, we will pick up some machine learning algorithms like naive Bayes. Naive Bayes algorithm will just pick it up. It's just a very simple algorithm to learn. Naive Bayes will pick it up and we'll go for the classification and we'll try to see how exactly the accuracy is. All right. Quick 3 minutes break. We'll go and come back and we can continue. Let me start. We'll be back at 8:16. Okay. 3 minutes break. All right, so everyone are back. Jagdish is back. Perfect. So let's continue this. So we learned about the theory of this bag of words and TF-IDF. So now let's get into this scripting part, and we'll try to work on that particular area. So now we are here. So what exactly we are trying to do, we done this particular data pre-processing and we take in this data. Now we are on the process of text pre-processing. So for text pre-processing, in order to go with this bag of words model, again, from NLTK, we're going to work with this thing itself from NLTK. Dot something called as, I think from SQL, we have from SQL. From SQL library, there is something called as feature extraction. Yeah, feature extraction dot, we are having text information dot text. There we are having, if we give a tab button, we are having count vectorizer. Count vectorizer. All right. So what is this count vectorizer is all about? So if you wanted to go with this bag of words model, to implement bag of words model, we need count vectorizer. So now let me come back, execute it, count vectorizer. Let me import it F9. It is done. Now count vectorizer, the class. Now what exactly this will do? Let me give a cursor, shift triple tap. One help window will get open here. If you just read it. So what are all the parameters it has, input it has. See, this convert a collection of text document to a matrix of token counts. That's what the point is. And it is having lowercase and a lot of things. Intelligence has stop words, English. In default itself, it is just going to do it. And since ngram, this is what as I said, the default is nothing but 1,1. That is, it is going to pick up one word at a time. In case if you're going with 1,2, see this. The lower and upper boundary of the n range for different words, n-grams or character to be extracted. All values of n such that minimum is equal to n and will be used. For example, n-gram of 1,1 means only unigrams. 1,2 means unigrams and bigrams. 2,2 means only bigrams. So in this way, we are having 1,3 is nothing but unigram, bigram, and also trigram. So in this way, we can deal with this. So, and also very important feature, I would like to tweak it as nothing but here I'm having max features. So now what I'm going to do, max features, it's default. If none, build a vocabulary that only consider the top max features ordered by the items. So this parameter is ignored if vocabulary is not none. That is nothing but this part I'm just going to tweak it here. Why? Because here I'm having, with respect to my data, let me click on variable explorer. So here I'm having 5,570 observations, right? 5,570 observation. Let me click on this. Just do one small calculation here. I'm having 5,500 observation, and each and every observation is having, let's take 10 words. Each and every observation is having 10 words. So if each and every observation, if it is having 10 words, for 5,500 observation, how many words I need to create it as a column? How many columns I have to create it? If it is a bag of words model. Great, Jyoti, this 55,722. So 55,722 columns to show it in my image itself, or in my Jupyter, sorry, in my Spider itself, it will take a lot of time. So to avoid that ambiguity, what I'm going to do, I'm just going to restrict this particular number of columns as maybe 200 or 1,000 or 2,500. Let me say 2,000. All right. I'm just going to pick up the first 2,000 columns, and I'm just going to process it. Just we are trying to understand and look into the accuracy of exactly it would work. So I'm just going to take it, count vectorize it. So after this particular process, let me store it into something like CV. Count vector. Let me click on F9. So this process is done. Count vectorizer, this is done. So now what I'll do. So this is nothing but my input, right? So since count vectorizer, if I'm just double clicking on it, if I'm just double clicking on count vector CV, that's the variable name, I'm not able to see it is a method and everything. So after exploration, I learned it that it need to be converted to an array format. So to array, let me give it F9. Okay, this says count vectors has no attribute called to array. So to underscore array at least. Okay, something here we have to do, that is, okay, fit and transform, we have to do it, right? So now this one is got done. Just this part is nothing but we are just initializing it. After initializing it, we need to convert this. We need to take this intelligence of this particular CV dot. That's a method. We are trying to convert this particular values to numbers. So there is another function called as fit and transform. Again, if it is what is this fit and transform, we will be spending good amount of time if we learn machine learning classes, but still we have not learned. Just for now, you can know it. It is going to convert all the words into numbers. Here, I have not provided just an initialization, like how we said, hey, this part, port or stemmer is equal to PS. That's what we have done. Now by using the CV2 dot, it's going to functions. I'm going to use it. Fit and transform, which I wanted to fit and transform my cleaned data, right? That's where my clean data is available. Let me copy. And this is nothing but my input. So let me give X is this nothing but X. Let me give F9. So this is done. Now, if I'm looking onto this X part here, I'm not able to see good data. So it is after exploring this, I got it. So if I'm converting into an array format, 2 underscore array, all right, F9. Now, if you look onto this X part, array of, see this 55,572, 2,000 observations you have. If you double click on it, we want to continue anyway. See this? This is what we call sparse data, 0th column, first column, and everything you have. Scroll down, this will just keep moving to the right. And you can find some numbers like one, I'm just scrolling down here. See this? This is what we call sparse data, 1, which means that in 116th sentence, I'm having a token of this 107th token. You can just display it here. That's not the major goal here, but just trying to understand how exactly the data got constructed. In this particular 116th sentence, I'm having this particular word 107. So I got it. Even if you scroll down, you can find this 121 sentence is having 128th token, and the 123rd sentence is having this 127th token. Even there are sometimes you will feel 2, 3, somewhere you will also see this. Only not 1, maybe you can find 2 also somewhere. All right, maybe you're not finding it here for now. But if you scroll to the right, see this part, if I'm scrolling to the right, it will keep moving. But because it is trying to display the 2000 observations, it will take a lot of time. But again, it is not our goal to see this, what are the 2000 features are, that's not required. We just converted it. Now machine is going to learn this pattern. Okay, if this 0, 0, 0, 0, 0, if this is the pattern, this is going to be output. I have not given, only input I prepared it, output I will be attaching it here. So now let me close this. Yes, so Amar is saying, please stay in the meeting till last minute. We are going to share some information about certification and upcoming AA program. All right, fine. So thanks for sharing that information, Amar. So now see this, I got this particular X here. Now I wanted to prepare this Y. So prepare this Y. My output, it is in something called as list. Let me click it. Sorry, my output is somewhere in this spam ham data, where exactly this is label. This label I have to do it. It is in something like an English text information. I would like to go with an encoding technique, where exactly for ham, I will just go with 0. And for spam, I will just encode it to 1. So for that, I'm having one library called as label encoder. Again, this part we will be learning in machine learning part. For label encoding techniques or text encoding techniques, we will be learning it over there. So from sklearn dot, I would need this pre-processing. I'm importing something called as label encoder. All right, now again, let me initialize this label encoder to this LE. All right, now once this part is done, now I will be fitting my data, which I have to label encoded. So LE dot fit and transform this the spam ham data, spam underscore ham underscore data of this particular column, that is label. I do this and I store it into output Y. Let me click on F9. It is done. Now we can scroll down and you can find this particular part, X and Y. All right, this is my input and this is nothing but my output. Call it encoding techniques I have. Now I choose one machine learning algorithms. So now text pre-processing is done, vectorization is done, input and output I separated it. Now let me choose one machine learning algorithm called as um, SKLM dot one algorithm we have like naive-based algorithm. Import one. The algorithm name is multinomial naive. So what exactly? In short, let me keep it simple. In short, what exactly this will do? It is a conditional probability. That is, it is having an equation probability of A given B is equal to probability of B given A multiplied by probability of A divided by probability of B. In this way, it will be taking one mathematical equation. You can understand in this way, what is the probability of this message being a spam? It's a continuous joint probability, I can say. This message being a spam, when the words are like lottery, win, all right, and congratulations. In this way, I'll be taking all the words to the right hand side. I'll do this particular calculation. If the final probability, if it is equal to 0, then I'll say it is a maybe zero. We have just given it for ham messages, right? Ham messages. If the result, if it is equal to 1, we will say it is a spam message. That's what we do it over here. So finally, this is in short about this naive-Bayes algorithm, just a mathematical equation explaining behind the same. So now let me take this multinomial naive-Bayes. So now I'll take this multinomial naive-Bayes, all right, multinomial naive-Bayes, and let me give this intelligence to NB, something like this. And now let me click on F9. 1 by 2 50%. Again, we just go with the probabilities going. If the final probability, if it is less than 0.5, it will be classified as zeroth class. If it is greater than 0.5, it will be classified as first class. In that way also it will work. Okay. So now NB dot, let me close this. So now let's say NB dot model initialization is done. NB is not defined. Let me copy F9. So once it is done, now I have to fit my data set NB dot fit. Again, it's all about machine learning sessions. So I have to fit my input and output. My input is available in X and my output is available in Y. All right, my output is available in Y. Let me click on F9. Training is done. Now I want to go for a prediction that we provide NB dot. I'm having a function called as prediction. NB dot prediction. Predict. So to this, I did not have any new data set. So let me pass the original question paper itself to it. Question paper is available in X. Let me try to store or take the result in something called as Y underscore prediction. F9 and a variable explorer. I got this Y prediction result for all the question papers. Now I wanted to go for evaluation. So let me take from SKLN dot metrics. Let me import one of the matrices. One of the metrics is accuracy score, F9. So accuracy score will take the value from what is the Y true. Y true is nothing but my actual output. My actual output is available in Y, and the predicted output is available in Y predicted. Let me click on F9. So the final accuracy, if you're able to see, it is 98% accuracy. So now what we do, we try to take this, we import pickle. All right, we import pickle, F9. And with respect to pickle, sorry, from pickle, we try to load this dump. So from pickle, let me import dump, F9, F9, and then this binary file is giving us a good result. So what we do, so not dump, yeah, dump. I'll just open a file with the name. Sorry, first I have to give this particular file name, that is NB. This is an object, and open up a file name. Let's say it is spam ham intelligence. Intelligence dot pickle file something, and then I'll just give a write bytes. So everything will be working on it if it is a machine learning program. Execute it. So now it is done. If you look onto this particular files, you will be having this pickle file as a binary file. If you're trying to open this, it will be completely it will be a completely kind of binary file which you won't be able to understand, but machine will be understanding it. So this kind of intelligence we try to give it for a multi-class classification, or there are other evaluation metrics as well. I just executed only accuracy score. There are a lot of other ways how you need to look into your data set and how you have to come to the conclusion. How do you, there are a lot of steps to evaluate your model. One of the steps is this particular accuracy. There's a lot of things like precision, recall, trade-off, sorry, recall, A1 score, F1 score, AEC curve, ROC curve, a lot of things is available. But to play with this text information, the client is not concerned about the steps what you're executing. So he's just concerned about this pickle file. Is it going to give you the right result or not? We will be checking it from our side and then we will be giving it up. So this is all about, in case if you wanted to work with this bag of words model, just you have to take this count vectorizer, remove this count vectorizer, and try to go with this TF-IDF transformer. Oh, sorry, vectorizer. You have it. Try that out. Maybe later you can, in your home, your free time, you can just try that out. So this is all about text pre-processing with NLP. So that's what I try to deliver. So we are taking a big text and we are text pre-processing it. So after pre-processing, we are choosing any one of the vectorization technique like bag of words or TF-IDF or word-to-vec model or BERT model. We are taking it. And once we get it, we choose one machine learning algorithm or a deep learning techniques for classification or for next sentence prediction or so. Got it, everyone? Only Jyoti. All right, Jagdish, Harsh, Rishikesh. Perfect. So with that, we are, wait, Malati. With that, we are winding up our 20 days of program. So hope we all learned well in this 20 days of program with ExcelR. I think you have taken some steps, even if you're a non-programmer, if you're following the same agenda. So you should be able to, if you're practicing it with the daily given tasks and everything, if you're enrolling into this machine learning program, data science program or AI program, there will be a mentor, means let it be me or a lot of other good trainers ExcelR is having with them. So you can, in case if you want any service, any additional service like looking at your assignments, some feedbacks. So ExcelR is having a separate assignments team with them. I think I've already told you all these things. So you can choose your program, you can choose your mentor, a lot of options they do have it. Maybe you can get in touch with the ExcelR team for more details for getting this kind of services, how they are making learners getting placed, a lot of things they are actually doing it. Okay, but this is the content what we try to deliver. And again, what I would say, it's not all about an ExcelR's hand, or it's not about me in my hand. How you are practicing it from your side, how you are making it possible, the time what you're investing from your side towards learning, that will take you to land up in a job. All right, I would say don't trust me or even don't trust ExcelR. Just trust you with respect to your process, whatever you're learning. Just try to take more time. The only reason why you have to enroll to a program is nothing but to cut short your time period to get into the job. So that's the major reason if you need to enroll into any program, or if you're having good amount of time, invest your time and learn these things. In the day when I have given you this proper roadmap, what are the step-by-step things to learn? So follow that. So that should be fine. Okay. All right. So Harsh, thank you for engaging and teaching for last 21 days. These sessions have been intriguing and insightful. This was my first ever learning anything related to AI. And this program has boosted my moral and interest to take further time into the subject on my own. Again, I would like to thank you for giving us this time. Wonderful, Harsh. Good message. Thank you so much. Good to know that you really got some sort of insights. Again, from here, there are a lot of things to learn. Given this points, so from here, just to try to get into all these details. All right, Jyoti, good to know that. Thank you very much. Hi, Anil. Perfect, Anil. Great to know that. Hi, Astosh. Great, Astosh. So Anil, do you teach Angular also, sir? No, Anil, I'm not into those areas. That's for developer roles. I'm not over there. Great, Supriya. Thank you. Perfect. So, Jagdish. All right, Jagdish. Thank you. Nabila. Yes, thanks, Nabila. Hi, Vishwanath. Thanks, Vishwanath. Wonderful, Abad. Great to know that. All right, so good to have you all here in this Zoom platform. Even though we are far from the location, I think we all connected in this by using this technology, and we all learned it. We will use this technology, and let's use this technology for good learning. So with that, wonderful, Dr. Leela. With that, I'm just winding up. So now the team will be taking into this. We'll just get back to you, and they will be discussing about the certifications, and if there are any other programs that it is coming up, they will let you know. Okay. Take care, everyone. Happy learning. I wish you all the best for your future. Bye bye. Amar, you can just take it from here. Bye, Rashikesh.
Hello everyone. I'm just want to share the one information with you. Hope my voice is audible to everyone. Congratulations and thank you for being the part of this 40 hours live virtual artificial intelligence EDL program. Those who have attended the 60% of sessions, they will get a certificate within the next 5 to 6 working days. You will receive a mail from ExcelR. Keep checking in draft as well as in spam. If anybody is facing any difficulties, then please drop mail at edl@excelr. And one more thing, in second week of May month, we are coming with Python for DS, and you will get the registrations link on your email. So please stay tuned. Thank you. Happy learning from ExcelR.